Good morning one and all. Now I am going to discuss some problems about the Laplace transforms whose functions are involved in the trigonometry, that is sine and cos. Okay, I am taking problem that is find the Laplace transforms of the first problem is cos 3t sine 5t. Cos 3t sine 5t. Second one is 3 cos 3t cos 4t. 3 cos 3t cos 4t. Third one is sine of omega t plus alpha. Sine of omega t plus alpha. The first problem is let f of t is equal to cos 3t sine 5t. Here we know that cos A sin B, 2 cos A sin B is equal to sin of A plus B minus sin of A minus B. Sin of A plus B equal to sin A cos B plus cos A sin B. Sin of A minus B equal to sin A cos B minus cos A sin B. In the second terms cos sin relation is there. So we subtract from one to other. The first term sin A cos B get cancelled. We are getting the 2 cos A sin B equal to sin of A plus B minus sin of A minus B. By using of this relation, in the place of A, 3t is there. In the place of B, 5t is there. And this is 2 is taken to this side. Then it becomes f of t is equal to cos 3t sin 5t is equal to 1 by 2 into sin of 3t plus 5t minus sin of 3t minus 5t. Okay. This is equal to 1 by 2 into sin 3t plus 5t, that is 8t, minus 3t minus 5t sin minus 2t. We know that sin of minus theta is equal to minus sin theta. Substitute here, f of t is equal to cos 3t sin 5t is equal to 1 by 2 into sin 8t minus into minus plus sin 2t. Taking Laplace transforms on both sides. Taking LT on both sides. L of f of t is equal to L of 1 by 2 into sin 8t plus sin 2t. Okay. By using of linearity property, L of f of t is equal to 1 by 2 into L of sin 8t plus 1 by 2 into L of sin 2t. We know that the important properties of Laplace transforms. L of sin 8t is equal to a by s square plus a square. By using of this relation in the place of a, in the first case 8, in the place of a, the second case 2. So L of f of t is equal to 1 by 2 into 8 by s square plus 8 square plus 1 by 2 into 2 by s square plus 2 square. Then L of f of t is equal to 2 ones are 2 fours are 4 by s square plus 64 plus 2 to get cancelled 1 by s square plus 2 to the 4. This is the solution of the first problem. Okay. The second problem is second one is let f of t equal to 3 cos 3t cos 4t. Here we are using the 2 cos a cos b formula. We know that cos of a plus b equal to cos a cos b minus sin a sin b. We get the cos a cos b values, means just we add the cos of a minus b and cos of a plus b is b plus cos of a minus b. Here this 2 is taking to this side, then cos 3t cos 4t is equal to 1 by 2 into this f of t equal to 3 cos 3t cos 4t means 1 by 2 into 3 is taking outside 3 by 2 cos of 3t plus 4t plus cos of 3t minus 4t. This is f of t is equal to 3 by 2 into cos of 70 plus cos of minus t. It is equal to 3 by 2 into cos 70 plus cos t. Why? Because we know that cos of minus theta is cos theta only. Okay, taking Laplace on both sides. Taking Laplace transforms on both sides. L of f of t is equal to L of f of t is 3 by 2 cos 7t plus cos t. By using linearity property, 3 by 2 right outside, L of cos 7t plus 3 by 2 L of cos t. By using the property, that is the Laplace transforms property, L of cos 80 equal to s by s square plus a square. Then L of f of t is equal to 3 by 2 into, in the first case a is equal to 7, then s by s square plus 7 square plus 3 by 2 into, in the second case a is 1, then that is s square plus 1 square. So in this, taking common 3s by 2, 1 by s square plus 49 plus 1 by s square plus 1. Taking LCM and you leave up to here only. If we take LCM, 3s by 2 s square plus 49 into s square plus 1. It is s square plus 1 plus s square plus 49. 2s square plus 50. 2 is taking common. L of f of t is equal to 3s by 2. 2 taking common, s square plus 25. Why? Because the sum constant is 50 by s square plus 49 into s square plus 1. These two get cancelled. Then L of f of t is equal to 3s into s square plus 25 by s square plus 49 into s square plus 1. It is the solution of the second problem. Next, third one is, it's very simple. Third problem, let f of t is equal to sine of omega t plus alpha. Here we are using the formula of sine of a plus b. Sine a cos b plus cos a sine b. Okay. Here f of t is equal to sine omega t into cos alpha plus cos omega t into sin alpha. Okay. Taking Laplace transforms on both sides. L of f of t is equal to L of sin omega t cos alpha plus cos omega t sin alpha. Here cos alpha is a constant, sin alpha is a constant. By using linearity property right outside, cos alpha into L of sin omega t plus sin alpha into L of cos omega t. It is equal to cos alpha, again using of Laplace sin at, that is a by s square plus a square, that is in the place of a w is there, plus sin alpha into Laplace of cos omega t is s by s square plus a square, that is omega square. Here in this two cases, taking 1 by s square plus omega square, the remaining terms are omega cos alpha plus s sin alpha. Here L of sin at is a by s square plus a square. L of cos at is equal to s by s square plus a square. By using those formulas or those properties, we get the L of f of t. This is the solution of third problem, the Laplace transforms of the given third problem. Okay, thank you very much.